In today's experiment, you will determine the molar absorptivity of a prepared stock solution of blue food dye and make a calibration plot of absorbance versus concentration. Finally, you will use the slope of your best fit line to determine the concentration of an unknown solution of the same dye. We will be using a spectrophotometer as our light source, and the difference between the I sub O, or original intensity, and the I sub T, or transmitted intensity, is the absorbance. How much light of a certain wavelength is being absorbed by our solution. Using this value, we can determine the concentration of our solution.
Okay, let's start by making sure we have all of our materials. First, we will be using a Go Direct SpectraViz Plus spectrophotometer that can connect to your iPad. So this lab will require your iPad to have Bluetooth connectivity so that you can connect to the spectrophotometer. Also, we will be using a stock solution that was pre-made. Please take note of the concentration of the stock solution and also note the units. This one, for example, says 3.74 micromolar. So that's micro moles per liter. And you'll need to look up the conversion factor between moles and micromoles. Also, we have 8 test tubes, at least 8 or more cuvettes that we'll be using with our spectrophotometer. You'll need a pipette that can measure up to 10 milliliters and a pipette pump, some deionized water, some glass beakers, and a stir rod. Let's begin. So the first part of the lab says to obtain about 40 milliliters of your stock solution in one of your beakers. In the other beaker, you'll add about 40 milliliters of deionized water. You'll use these beakers to pipette from. Try not to cross-contaminate your solutions. Use one pipette exclusively for your stock solution and a different pipette exclusively for your water so that you don't get cross-contamination. Our technique for pipetting is to first take note of the scale. Notice that for a graduated flask such as this one, the scale is written upside down, meaning that if you pipette 1 milliliter, you're actually pipetting up to the 9. If you pipette 2 milliliters, you're actually pipetting up to the 8. If you pipette 2.5 milliliters, as you can see here, not only are you pipetting between the 7 and the 8 to the half point, but see how many significant figures you could read from this measurement instrument. 1, 2, 0.5 milliliters are clearly noted, and we'll have to estimate 1 additional digits, so that would be 2.50. 3 significant figures in milliliters can be read from this pipette. You're going to add your pipette to your pump and go ahead and lower it into your first solution. Now there's 2 ways to use the pump. The first way is to roll the wheel upwards so that your pipette fills with solution. As I roll, I'm getting more and more solution, okay? Then when it's time to transfer your solution, you have the option of either rolling down to empty your pipette, or you could push the quick release button here and that will empty it for you. So those are 2 options. So let's get started pipetting. In each of my test tubes, I'll be adding the prescribed amount of stock solution. For the first test tube, it says that I should add 1 milliliter. Pipette to 1 milliliter. Really get down to eye level so that you can read clearly while you're making your refinements. So the bottom of the meniscus is on the line here. And I'll release that into my first test tube. Don't worry about the remaining bit that is actually calibrated within the instrument itself. I've finished pipetting all of my stock solution, and you should see a pattern, right? Each test tube has successively more stock solution until I get to the one that has the 10 milliliters. Next, you're going to take your set of cuvettes and fill each one with the solutions that you've made. It does not have to be filled exactly to the top. But if you overfill a little bit, you can just wipe it off. Again, your cuvettes will show the succession of the dilution where you've added more and more solute, the brilliant blue. So first you'll turn on your Go Direct. You'll see a green light. It will flash blue until you are connected to the Bluetooth. Our next step will be to download the Vernier Spectral Analysis app.
You will select the lab that says concentration Beer's Law. It will ask you to look for your SpectraVis, the one that has the matching sequence number. Press connect and wait. Once you've connected, it takes about 1.5 minutes for the lamp to warm up. Blank meaning with only water.
We'll start by adding our water-only sample and wiping off the cuvette so that the clear side does not obstruct the light and allow the software to collect that data point.
Please pardon my stubborn mispronunciation of the word cuvette or cuvette. Cuvette is a French word referring to a small, often transparent laboratory vessel. We use these vessels in a spectrophotometer because their sides allow light to pass through unobstructed. You'll notice that before I enter the cuvette into the spectrophotometer, I wipe it with a chem wipe tissue in order to remove any oils or objects that might impede the passage of light. Press Finish Calibration. Allow it to set what is essentially the zero, the sample that has only water in it. Then it will show you the beginning of a graph, the baseline, the zero measurement. Now it says remove the blank curvette, insert a sample, and the sample that we want to use is our stock sample. So we'll take the zero sample out and add our stock sample. That's our 3.74 micromolar, or whichever value you've recorded, sample. Once we do that, we get our lambda max curve. Set the desired wavelength, step 3, by tapping the graph or entering the value. So I'll tap the graph until I get to what looks like the maximum. Tricky little point there. And record that value, 630 nanometers. Done. Now that we've told the spectrophotometer what is the appropriate wavelength of light to get the maximum absorbance, now we can start collecting data. Press Collect and enter your first sample. Your first sample at this point should be your zero sample again, your sample with only water. Note the absorbance value on the bottom right-hand side of the screen. It is adjusting, so very little of the light is being absorbed as we would expect from a sample that is just water. Now I'll press Keep and enter the concentration. Right now it's 0 molar, and I get my first data point on the graph.
After we press Keep and enter the proper concentration in moles per liter, we'll and continue successively.
Next, enter my second sample. Note the absorbance and record it in the data table on your lab and press Keep again. Be sure that the concentration you enter is in moles per liter, not micromoles per liter.
At this point, you should have already calculated the concentrations of each solution, but note that those units are in micromolar. Micro, the Greek letter U or mu is used to represent micromolar, which means moles per liter. But the unit that we will be entering into our spectrophotometer is molar, or moles per liter. So we will need to convert micromoles into moles, or moles per liter. The relationship here is that 1 mole, or 1 mole per liter, is equal to 1 million, 1 times 10 to the 6 micromoles. So each one of these values that you've already calculated will then be divided by 1 million. Let's do the first one together. And the value that we get is 3.74 times 10 to the negative 7. So in your spectrophotometer, you will have to add 0.000000374.
See, we have a data point at the lowest and a data point at the highest. We'll continue.
Press keep, enter your concentration in moles per liter, and continue.
This is our last sample. Press done in your app and remove the curvette with the full strength solution. Once you have collected data from all 8 of your known samples, use the software to add a linear trend line to your data points. This trend line will be accompanied by an equation and a slope value. You can use this equation and slope value data to help you calculate the concentration of your unknown solution given its absorbance. Our last step is to test the unknown. Here's a stock solution of brilliant blue that we do not have the concentration for. However, we can fill a curvette and measure the absorbance and calculate the concentration. This is the last number we need. The absorbance value of the unknown solution is what we can use and compare to our standard graph and our equation from our standard graph in order to obtain the concentration of the unknown solution.